Hello and welcome back to College Algebra MAT 150. In this video we'll be finding the domain and range of a function. So what is the domain? Well, the domain is everything that, every value that we can plug in. So it's the set of inputs. So what can we plug in, what can't we plug in? And in general, if we can't plug it in, then it's not part of the domain, namely that we want to have an output that is real valued and exists for that matter. So for example, we can't divide by 0, and inside of square roots or any root with an even index, we must have positive values or 0. We can't have negative values inside a radical with an even index. So, what do? Well, we find out what values make this work, and we either exclude them or we just talk about all the ones that do work. So, for example, in this function f of x equals 1 over x minus 2, we can't, the denominator, which is all of x minus 2, cannot be 0. All right? So it can't be 0. So instead, what we do, we set it equal to 0 and solve. So we add 2 to both sides. And the value that we get, so set it actually equal to 0. So we know that it ultimately shouldn't be 0. So we set it equal to 0 and see what values those become. And if x equals 2, well, we'd have 2 minus 2. And that's 0 in the denominator. And that's something we can't have. So we can't let 2 be an input for f. And again, the domain is the set of all viable inputs. So if we let 2 be here, we can have everything but 2. And this looks like this on a number line. So what is the domain? The domain is the set of all, so we write it in interval notation. We go from negative infinity up to 2, union 2 up to infinity. So basically every number but 2. So we can have 1.99, 1.999, 2.01, 2.1, anything like that. Again, as close to 2 as we want to get on either side, just not 2 itself. So this is what the domain is. So we usually write domains and ranges in interval notation if it's applicable. For this other function, so for g, so we can't divide by 0, but in this case we have a radical with an index of 2. Again, if you don't see an index, a little number in the divot there, it's always assumed to be 2. And it can't be negative, but it can be 0, and it can be greater than 0. It can be positive, so greater than 0. So what you do is you just set the inside of that greater than or equal to 0, and then you solve in your favorite way. So 1 is greater than or equal to x. And we see what this looks like in as a graph. So 1 is in the middle. All numbers less than or equal to 1. So that's here. And all numbers less than or equal to 1 are on that side. And the less than or equal to part gives us the bracket. And so the domain, D, with a subscript g, d sub g, is negative infinity up to 1. And that's it. And that's our domain. So if we divide by 0, if we have something under the radical of an even index, we may have issues. So if it's we have a denominator, just set the whole denominator equal to 0, and then solve and exclude that value. So we excluded 2. So if we had more than one solution, we would exclude those as well. Inside an even index radical, we set it greater than or equal to 0, solve, and that's our interval. Now, if it doesn't have those two restrictions, then for at this point in time, then there's nothing we can't plug in. So for number 3, is there a denominator? Is there a radical with an even index? No. Since that's the case, then we just say the domain of h is all real numbers. In interval notation, you can write it like this, which is fine. Or you can just write it with R as an R with an extra vertical line there. You don't have to do both. You can just pick one. So I'm just going to pick this if you just want to stay as consistent as possible. But you could also write that as a perfectly fine answer. So that's how you find a domain if there is, if you have some sort of equation. And I have a summary down here of exactly what we just said. So even index. So again, the index is in the little divot here. So we don't write 2. Again, if it's not written, it's assumed to be 2. Otherwise, it'll be written as 3, 4, 5, something like that. But if it's an even number, so 2, 4, 6, then you'd have to do this. For odd radicals, again, you wouldn't actually, you can do odd radicals, odd indexed radicals. And if you have a denominator, you see when the denominator is equal to 0, and you exclude those values. And otherwise, you don't have any restrictions. So another way we can talk about domain and range is by looking, or specifically the domain, we'll talk about range here in a second, is by looking at the graph of a function. And if you have a graph, all you're really trying to do is see how far left to how far right the graph goes. So, so when you're looking for the function, again, it's all the inputs, and the inputs correspond to x values, and the y's corresponds to outputs. Okay, so what we put in is x, what we output is the y. So question, what is the set of all of our inputs? Every time we can plug in a number, we get something out. Now these are very, very small, so let me increase their size just a smidgen. But the moment you see arrows, that means it goes on forever. So even though it's pointing pointing down and to the left, so it will go all the way this way. So the domain is again from negative to positive in interval notation, and we think of it going from left to right. So how far left does it go? Well, it goes out negative infinity. And we know there's a right arrow, so it's going to go to positive infinity. The only thing we have to worry about is there anything in the middle where it stops being a function. So we're trying to find any vertical line that might be a problem. So here, 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 and here, from negative infinity to 0 is fine. On the other side of 0, here, 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 here is fine. The only weird part is this point at x equals 0 in the middle. But this is a function, and it's defined here. So at x equals 0, that's what the dot is. So it's part of the domain. So this part is fine, everything to the left is fine, everything to the right is fine. So negative infinity to infinity. But what about the range? So first off, so in the previous problems, we only talked about the domain. We didn't talk about the range. Well, the only viable way, so there is one other way that we could find the range, but it's for niche situations. But generally, your default method of when you think, hey, how do I find the range? I need to look at the graph. And you try to find from basically how far down to how far up the graph goes. Okay, so down to up. And again, just like with the domain, we went left to right, that's negative to positive. We're going from negative to positive y values here. So how far down does it start? Well, both of these arrows point down. So parentheses, negative infinity. And how far up do they go? Well, again, we're looking about y outputs. So we're looking at horizontal. So does it go here, 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 here? Oh, here, this side stops, but it keeps going on this side. So it still has an y outputs until we get to this circle. So this little hole. So it goes all the way up to what value is this? Above 0, 1, 2, 3, 4. It gets really close to the number 4, but this open circle means it's a hole. It means it gets really, really close, 3.9, 3.99, but never actually touches it. And these are our domain and range for this particular function. Which again, it wasn't given to us with a formula, it was only given to us with this graph. All right, this concludes everything from section 1.2.